Hello everyone, and welcome back to our channel. Today, we have an extraordinary discovery that's bound to captivate your imagination. Astronomers have uncovered a fossil galaxy buried deep within our very own Milky Way. This fascinating find could change how we understand the formation and growth of our galaxy. Let's dive into the details. Scientists using data from the Sloan Digital Sky Survey's Apache Point Observatory Galactic Evolution Experiment, APOGEE, have made a groundbreaking discovery: a fossil galaxy hidden within the depths of the Milky Way. This result, published in the monthly notices of the Royal Astronomical Society, might revolutionize our understanding of the Milky Way's evolution. The proposed fossil galaxy, named Heracles after the ancient Greek hero, is believed to have collided with the Milky Way about 10 billion years ago when our galaxy was still young. Remarkably, the remnants of Heracles make up roughly 1/3 of the Milky Way's spherical halo. But why didn't we see it before? The answer lies in its deep location within the Milky Way. To find a fossil galaxy like this one, we had to examine the detailed chemical makeup and motions of tens of thousands of stars, says Riccardo Schiavon from Liverpool John Moores University, JMU, in the UK, a key member of the research team. This is particularly challenging for stars in the center of the Milky Way, hidden by clouds of interstellar dust. APOGEE allows us to see deeper into the heart of the Milky Way than ever before. APOGEE achieves this by taking spectra of stars in near-infrared light, which can penetrate the dust that obscures visible light. Over its 10-year observational life, APOGEE has measured spectra for more than 500,000 stars across the Milky Way, including its previously dust-obscured core. Graduate student Danny Horta from LJMU, the lead author of the paper announcing the result, explains, "Examining such a large number of stars is necessary to find unusual stars in the densely populated heart of the Milky Way, which is like finding needles in a haystack." To distinguish stars belonging to Heracles from those of the original Milky Way, the team analyzed the chemical compositions and velocities of stars measured by the APOGEE instrument. Of the tens of thousands of stars we looked at, a few hundred had strikingly different chemical compositions and velocities, Horta said. These stars are so different that they could only have come from another galaxy. By studying them in detail, we could trace out the precise location and history of this fossil galaxy. Since galaxies are built through mergers of smaller galaxies over time, remnants of older galaxies are often found in the outer halo of the Milky Way, a huge but sparse cloud of stars enveloping the main galaxy. However, since our galaxy built up from the inside out, finding the earliest mergers requires looking at the most central parts of the Milky Way's halo buried deep within the disk and bulge. Stars originally from Heracles account for about 1/3 of the mass of the entire Milky Way halo today, indicating that this ancient collision was a major event in our galaxy's history. This suggests that the Milky Way might be unique, as most similar massive spiral galaxies had much calmer early histories. As our cosmic home, the Milky Way is already special to us. But this ancient galaxy buried within makes it even more special, Schiavon says. Karen Masters, spokesperson for SDSM-4, comments, "APOGEE is one of the flagship surveys of the fourth phase of SDSS, and this result showcases the amazing science possible now that we have nearly completed our 10-year mission." The age of discovery doesn't end with APOGEE. The fifth phase of the SDSS has already begun, and its Milky Way mapper will build on APOGEE's success by measuring spectra for 10 times as many stars across the Milky Way, using near-infrared light, visible light, and sometimes both.